In this lesson, we're going to look at state changes and the energy associated with them, including the enthalpies of vaporization and condensation, as well as enthalpies of fusion and freezing. As a reminder, the three states of matter are solid, liquid, and gas. Going from solid up to liquid to gas, or any part of that, will be an endothermic process. Going from gas to liquid to solid is an exothermic process. First, we are going to look at the enthalpy of fusion. Remember, fusion is the word we use instead of melting. Enthalpy is just a type of heat energy, and we represent this with the symbol delta H and the subscript of FUS for fusion. And this is the energy needed to melt a substance. So if we're going from a solid to a liquid, the energy associated with that change is the enthalpy of fusion. Let's look at an example for water. The enthalpy of fusion of water can be given in a variety of units. For example, we have 79.7 calories per gram, 333 joules per gram, and 6.01 kilojoules per mole. All of these are equivalent values, they're just using different units, just like we can say something is 1 foot long or it's 12 inches long. Notice that each enthalpy of fusion has some unit of energy over some amount of the substance. So calories or joules are both units of energy. Grams or moles tell us about how much of the substance we have. When we look at the enthalpy of fusion value, we know it's 6.01 kilojoules per mole. It's a positive value. It's endothermic because energy is going into the system to get the conversion from solid to liquid. The reverse process from liquid to solid is known as freezing. The energy value is the same, but the sign is different. Because going from a liquid to a solid is an exothermic process, this will have a negative sign. So the number is the same, but the sign is different. So the enthalpy of fusion is 6.01 kilojoules per mole. The enthalpy of freezing is minus 6.01 kilojoules per mole. Similar to the enthalpy of fusion, we also have the enthalpy of vaporization, and this is for the phase change from a liquid to a gas. So it's the energy needed to vaporize a substance. Looking at water, we see that the enthalpy of vaporization, going from the liquid to the gas, is 40.7 kilojoules per mole. Going from a gas to a liquid, which is an exothermic process because energy is being released, the numerical value is the same, but the sign is different. So the enthalpy for condensation would be minus 40.7 kilojoules per mole. Here are some example values for enthalpy of fusion and vaporization for a variety of substances. Note that the enthalpy of condensation and freezing are not included in this list. If you have the enthalpy of fusion, you also have the enthalpy of freezing, you just need to change the sign. Likewise, with the enthalpy of vaporization, we also have the enthalpy of condensation once we change the sign. Note that this also gives the melting point and boiling point for these substances at the normal pressure, which is 1 atmosphere. If we change the pressure, we would change the melting point and boiling points, and we would also change the values of the enthalpy of fusion and vaporization. These are not values you need to memorize. If needed, they will be provided on the exam. Note, when doing homework problems or end-of-chapter exercises, you may find that a value is not given. It's perfectly fine to use the book as a reference to look up the value you need.